Hello Internet, my name is Quentin and this is Blondihacks. I'm working on my A3 switcher locomotive this week and we're going to do all of the detail pieces on the front of the smoke box. These are the things that really give the locomotive its face and lots of really interesting pieces to make, so let's go. The first thing I want to do is the half circle hand railing that goes around the top. There's 3 little stanchions that hold it in place, so I'm going to make those first. Got this piece of stainless round bar for the purpose. These things have quite an intricate shape and we need 3 of them, so that's going to kind of govern my methods here a little bit. The drawings do have a suggested order of operations for this, which looks pretty good to me, so I'm pretty much following it to the letter. I'll turn this down to a diameter that is going to be a suitable blank from which to make the stanchions themselves. This round bar that I have is a little bit oversized, so we're going to turn it all the way down, and then once that's done, I'm going to turn a threaded area on the end, and this is what's going to mount the stanchion to the smoke box door. It's also going to be useful for fixturing. There's only a thread at the bottom of it, so I'll Sharpie that up and mark that with a tool so I know where to stop with the die, and then I'll put a thread on that area. And there's an unthreaded shoulder above that. That's really all I'm going to do from this setup, so I will part this thing off now to final length. This is the final length of the whole thing once all of the spherical and tapered areas that you can see in the drawing in the corner are added. And Yahtzee. I brought all 3 stanchions to this point. They all need a cross hole through them now, and I think the easiest way to do that is going to be a drilling jig. So I've got this scrap of steel that I found in my bin. I'm going to center up on this, and I'm going to make a drill guide. I'll start by drilling the drill guide itself all the way through the top, and then from one side I'll use an end stop to rotate this without losing my X position so that I can drill and tap on the side for a little brass tipped set screw that's going to hold each of these parts in the jig. Then I'll turn it up on end and drill the hole that holds the actual part. Normally a part like this I would do in something like a collet block since it's a simple cross drilling operation. However, they're a weird size and I don't have a collet that size, and they also aren't very big, so I'm not sure I would have clearance for the drill chuck and so on if it was held in a collet block. Plus I need to make these 3 and 6 more of them later, so this drilling jig will definitely get a lot of use. So that part holding hole is deeper than the part so that I can align it with the shoulder. Let's go ahead and do that now. I can feed the first part in there and align the shoulder with the front edge of the fixture. That's where the distance for the drill guide hole itself was calculated from. And then I can tighten the brass tipped screw and away we go. You can drill that straight through. This little drill guide only takes about half an hour to make, and it's well worth the time because, as I said, I have 3 to make now and 6 to make later when I do the rest of the handrails on this locomotive. Now I broke my cardinal rule of fixtures, which is always think about how you're going to get the part out after the operation is done. Drilling that cross hole locks everything together with the burrs on either side of the hole, and so it's quite stuck in there. Normally I would drill that part hole all the way through so I can push it through from the other side, but forgot to do that. So instead, some pop can and my parallel jaw pliers, and I managed to get that out of there. So, not ideal, but the result was excellent. It looks really good. So I will do the other 2 that way, and that drilling jig is a winner. That will go in the drawer for later use again. Straight over to the lathe to make another fixture now. I've got a piece of scrap steel. I'm going to face the end of this and put a thread and a counter bore in it that will allow me to hold all of these stanchions by that threaded end so that we can do all of the details on the other side. Now I can thread this piece in there, see if it goes all the way in. If it threads right up to the shoulder, then it'll be held securely even though that stem is quite thin and delicate. There's red Sharpie on this part and now all over my hands because actually I scrapped 2 of these blanks when doing the cross drilling. I forgot that only one of them is supposed to be a through hole. The 2 on the ends are blind holes, and so I got to make 2 more blanks, but that's actually going to come in handy because it's going to give me some practice pieces for the next steps. I'm going to mark off 2 diameters on this piece for where the tapered area goes between the base and the spherical top. So I'm going to turn that with my compound. I'll set this over to 3 degrees. The drawing calls for a 6-degree included angle on this area, and I will turn that. The drawing gives a dimension for the narrow end of the taper, so I'll go down a little bit at a time until I measure basically that diameter. This is all cosmetic, nothing too accurate here. We don't have to do any elaborate math. Those 2 pieces that I scrapped came in handy here because I really did need 2 practice pieces to get this process down. There's a fair bit of skill involved in getting this taper just right, and then the little spherical end above the taper just right. And I really definitely got better at it. I made a few mistakes on the first one, and I'm glad that I had those practice pieces. So scrapped parts, not always a bad thing. So a few passes with the compound gave me that little tapered area. Now for turning the ball on the end, I considered a few different options. I considered setting up the Tornado, for example, which does have a profile cutting feature and a ball turning feature on it. But because they're so small and they're stainless, I decided good old-fashioned filing was the way to go. Filing a hemisphere is really not that difficult because it's a straight, smooth 90-degree motion with your hand. So just take your time and do lots of passes. Don't run the lathe too quickly or the file will chatter. Files chatter just like anything else if you exceed their material removal rate. But some smooth 90-degree motions and you get a pretty convincing looking hemisphere. That looks good. Now the inside one is a little trickier because it's only a partial sphere and I have to try and not mess up the tapered area. So I've got the safe edge of my file down against the taper, hopefully to not damage it. And that worked okay, but this is where the practice piece really saved me, because when I was done, the corner of the file did damage the taper, even though I was using the safe edge, and it got too thin in there. I was also pretty unhappy with the finish on all of this, so on subsequent parts, I left the taper a little thicker, and then did the hemispherical filing, and then used the edge of my file to bring the tapered area down to the damaged area, if you will, that the file left. So I left myself extra thickness so that I didn't get the taper too thin, and then I also finished with a lot of emery paper to improve the finish. Since this is stainless, the filing doesn't leave the best finish. Lots of learnings on the first 2 parts. Again, I was actually grateful in the end for the scrapped parts. These are the 5 that I made, left to right in order. You can see I definitely got better at it. I ended up using the 3 pieces on the right. They aren't actually the best spheres, but these 3 pieces look the most alike. And I felt it was more important that they all look the same rather than that they have the best spheres on the ends of them, if that makes sense. And I decided they deserved a little bit better finish yet on the ends, so I used that holding fixture again, this time in my drill chuck, to give them a little spin on the cheater wheel. There are very few machinist mistakes that the Scotch-Brite wheel can't make go away. I'll need nuts for the backs of those to hold them onto the smokebox door, so grab some hex bar stock, and I'll zip through this. You've seen me make nuts before. Face, drill them all the way through. I'm making a batch of 3 all at once. Thread the whole batch all the way through. Get out the parting blade, chamfer the ends because we're not animals. Yahtzee them off, and Bob's your uncle will chamfer the back too because we're not animals. And, Yahtzee, Yahtzee, Yahtzee. You know the drill. Now over to my little slip roll. I'm going to make the curved railing that goes between all 3 of these stanchions. I'm going to try to do this with the bar rolling feature on this machine. It's something that I've not had a lot of luck before, but in principle it can do this, so I want to try again. And I've learned a few things on my past attempts at this, and this was actually working better. I might slowly but surely be getting the hang of this machine. I have a love-hate relationship with it. It's not as easy to use as I'd hoped it would be. There's a lot more skill in these sheet metal type machines than it would seem if you've watched people use them on YouTube. This actually was going really well, except that I ran out of radius on this machine. The minimum radius that it will do on this roller is still too large for my piece. So I got most of the way there, but I had to finish with some good old-fashioned hand bending on a piece of scrap round bar. That did work pretty well, though, that machine. So I think if you get better at it and stop blaming the machine for your failures, then they're good machines. Once I was happy with that, I chose a section of this piece that looked the roundest, if you will, and then marked one end and cut and filed that off. And then I threaded the middle stanchion all the way around and installed it in the right-hand stanchion and then cut the bar to length on the left-hand side. This way I didn't have to try and measure any tricky round circumferential distances, yada yada, something math. What am I doing here? Is this a YouTube channel? I snuck up on this dimension with filing because the blind hole in the end stanchions is not very deep, so I did a lot of filing and test fitting until I had the length just perfect. And all 3 of them slotted in there, and I could install the nuts on the back, and there we go. One curved hand railing. pretty pleased with that. It's not perfect. The roundness of it is a little suspect in areas, but you know, it's a working locomotive and I think it looks good. The next feature is a big round number badge that goes on the front. And for that, I've got a piece of brass from the scrap bin that looks to be the perfect diameter, so that'll make a nice number badge. Over to the lathe for that. The nominal diameter of this stock is basically the same as the number badge is supposed to be, so after facing the front, as is tradition, I'll turn this down, but I'm taking a couple of light cuts, a couple of test cuts to see what's the lightest cut I can take that will clean up the bar. And that ended up being about 8 thousandths undersize, so don't tell anybody that my locomotive has a number plate that's 8 thousandths too small. I mean, you can tell someone, but then you're just a jerk. You need a very shallow counter bore on the front of this for the number itself, and I'm going to use my Morse taper end mill holder and a 2-flute center cutting end mill to get this started for the boring bar. And yeah, you can put an end mill in a drill chuck if you want. You're really not supposed to do that. Look, I'm not going to judge you. We've all put things in drill chucks that we shouldn't, but end mill holders are cheap and easy to acquire, and they do a much better job and won't damage your drill chuck. So an end mill makes a nice starting spot for the boring bar. It does not leave a flat-bottomed hole because there is an end clearance on an end mill, so you get a little bit of a positive cone there, but that's easy to flatten out with the boring bar and then take it out to final dimensions. Now I'll mark the thickness of the outer disc area itself. That's going to give me a guideline for turning the tapered area that's on the back of the number badge. This thing is kind of funnel shaped, so I decided to turn the stem area down using a chamfering tool, because that will give me the 45-degree angle that's supposed to be on the back of the number plate kind of automatically, if you will. And the finish on the inside is going to be terrible for the moment because the end of my chamfering tool is very pointy. There's no nose radius on it, but that's okay. We're going to be removing that at the end with another operation. Now, I should say at this point, I had a couple of different thoughts for order of operations on this, and the one I landed on was similar to how we just did the stanchions, which is to turn the threaded stem on the back of the number plate first, and the taper feature and so on, all in that setup, then flip it around and hold it in a threaded mandrel to turn the shallow counterbore. Simple, right? And that was my plan. And then I put the stock in the lathe, and for some reason my brain just switched into the other idea I had had the night before, which was to do it all in one setup, as you see me doing here. And I mean, this was kind of fun, and it also saved me having to do any math, because I could just kind of turn the tapers and the shoulders that are all on this part one after another, and until they all kind of lined up. I didn't have to do any trig to figure out the width of the tapered area for each thickness of shoulder and so on. There's quite a lot of features on this part, multiple shoulders, multiple tapered areas, and doing it this way I didn't have to do any of that math. But as you have probably already guessed, it leaves me with a conundrum. Once I've got this stem turned down with the grooving tool and I'm ready to part it off, I still have to get the thread on the end, and it's now in a place where I can't access it with the die. I could, in theory, single point it at this point, but there's very little space in there, so even if I wanted to set up the change gears to do that, I'd have to grind a special tiny threading tool to get in there, and there isn't enough area for a run out. Like, it just, yeah, single pointing that would be a nightmare, even if I wanted to do that, which I don't. So, well, sometimes an order of operations is perfect except for one step that completely paints you into a corner, and that was this approach here. So, as is often the case with me, I end up doing one step at the end in an incredibly stupid way because I painted myself into the aforementioned corner. And here we are. I'm attempting to cut this thread with the die stock sitting on my bench and trying my best to keep the part straight and turning it with my smooth jaw parallel pliers because they can grip it very firmly without marring up the surface. If I had a dime for every time Knipex pliers have bailed me out of a stupid order of operations, well, let me just say that these pliers have paid for themselves. And I've been reliably informed that they're supposed to be called Knipex pliers, but I don't know, that just sounds dumb to me, I'm sorry, so I'm going to keep calling them Knipex pliers. Regardless, that worked way better than it had any right to. I completely got away with that. Metric horns of bullet dodging, and that part actually came out really nice. Let's thread that in there and see if it fits. So there's a shoulder at the top of it that seats into that counter bore on the smoke box, and then There's a little shoulder on the back of that tapered area that seats down against the door and makes it very sturdy. And that looks really great. I'm very, very pleased with that. My order of operations may not have been the wisest, but I got away with it. And that is looking good and actually very, very strong. So that's encouraging. While I'm here, I marked the bottom of the badge when it's in the fully tightened position. And then I transferred that Sharpie to a scribe mark on the underside so that when I go to attach the number to this, I know which way is down. That should guarantee the number is clocked correctly when the badge is installed. There's nothing more embarrassing than a crooked locomotive number. Big decision time now, though, what number to actually put on there. I haven't actually chosen a number for this locomotive. I knew the typeface needed to be Times New Roman because that's what Canadian Pacific used in 1915, and that's what is in the tender livery. So I looked at all of the digits in Times New Roman, and I needed to pick something that was a compromise between aesthetically pleasing and a number that I happen to like and is reasonably easy to make. That last criteria, for example, pretty much rules out the 8 and the 3. Those would be very difficult to create, even though I like 3 the best aesthetically. And I ruled out 1, 4, and 7 because they're too boring and they don't really look like Times New Roman. Not very interesting numbers. So I kind of landed on 5. 5 felt like a mix of aesthetically pleasing, reasonably easy to make. So then I just had to figure out the size. I gave myself a few options and printed out a few copies of that so I can do some experimenting. Then I took that and I very carefully Sharpied out 1 digit so that I could hold it up to the badge and make sure that the size is correct. It was too hard to tell with a bunch of white space around the number if it was going to look good on the badge. And I'm about to do a whole lot of work in brass, and I don't want to do that until I'm absolutely positive that I have the scale and the size of this number correct. So I didn't quite make it in one piece, but as you can see, the reassembled paper 5 on there looks to be just the perfect size. Now I did a few iterations on this. I didn't get it right first try, but this size right here, which happens to be 57 point type, looked perfect. Super happy with that. All right, brass time. So I got a chunk of brass and I got some spray glue on there. I cut out another 5 and I spray glued that onto the brass. And my plan is simply to cut and file around the printer ink on that 5 to get the shape. I considered a few other methods for doing this. I mean, obviously, I suppose you could CNC it if you had some sort of tiny desktop CNC machine. I know those do exist. I also considered etching it with ferric chloride, but it's really too thick for that. It's 40 thousandths thick, this number, and ferric chloride, you can't go that deep. It's going to start undercutting and it makes a mess. So that wasn't really a good option. So just fret sawing and filing in the end. And this honestly wasn't very difficult. I thought this was going to be really hard. But if you just fret saw a little bit outside the line, leave some white space at the edge of the printer ink, and then hand file your way down to the edge of the printer ink a little bit at a time. I used every needle file in the box on this one. Every shape was useful in some situation or another. And go slow and check it a lot and, be patient. And yeah, it's really not that difficult. Filing is one of those skills that it's really worth acquiring because it's such a universal problem solver. There's very little that you can't do with filing. Now, quick test fit on there. It's still got the paper glued to the front. That's why there's that black mess on there, but that is looking really good. I stuck the whole thing in acetone for a while to dissolve the spray glue and get the paper off the front. And now, how to attach it to that badge. The drawing calls for silver solder here, and I waffled back and forth between soft solder and silver solder for quite a while. The advantage of silver solder, of course, is that it can stand high temperatures. And that might be necessary here because the number badge is attached to the smoke box, which is attached to the boiler, which of course gets very hot. However, silver solder is a little bit more difficult to do, and most importantly, it's virtually impossible to undo. If, for example, the number ends up crooked or something else goes wrong, and I want to remove the number or I want to change the number someday, that's virtually impossible with silver solder. And I kind of thought, well, it probably doesn't get that hot, the badge, because while it is attached to the smoke box is barely touching the boiler, just on one edge. And the number itself is sitting on that badge that is out in the air on a stem, so I doubt it gets that hot. It probably gets too hot to touch, but hot enough to melt soft solder? I really doubt it. I think the drawings probably just recommended silver solder here because that's Kozo's default. He uses it for everything. Soft solder will be much easier though, and if I mess it up, if the number ends up crooked or something, it's easy to heat it up again and move it. And then of course it's also easy to change the number later if I want. So I went with soft solder, and if I find out later that this does get too hot and the number falls off, well, someone at the club track someday is going to be finding a nicely handmade brass 5, and they're going to start calling me Old Quinn No Number, I guess. Or Thomas the Dumb Engine. I don't know. They'll come up with some good name to mock me for my lack of number. I put a little flux on there, and I hammered a piece of solder very, very thin over on the anvil, like paper thin, so that I could just tear it into a couple of little pieces that would sit under the number and would allow the number to settle down into the solder as it liquefied. I was trying very hard to avoid any kind of solder fillet around the number because that would really destroy the look of it, and any fillet that ended up in there would be essentially impossible to fix because you can't get any kind of file or anything in there. So I basically tried to use as little solder as I possibly could, and I'm pleased to say that seemed to work. There's like 18 molecules of solder holding that number on, but the joint itself looks invisible, and I double checked my down mark on the badge, and it looks like the number is correctly oriented. A little cleanup and some pickling acid, and I am stoked. I think that came out beautiful. I was quite unsure how I was going to manage that. This is much more of an artistic kind of thing than I have ever made before in my shop, and I gotta say that came out really nice. If I don't mind tooting my own horn a little bit, I am extremely pleased with how that came out. And if I ever want to change the number, it's just soft solder, so I can melt it off of there. Or whoever finds that 5 on the tracks can put it on their locomotive. It's win-win. I went to install this on the front of the smoke box now, and I ran into a little issue. The nuts that hold the handrail stanchions on are actually fouling on the mounting bosses for the door. And I kind of thought this might happen because they're very close together, as you can see, and that is in the drawing. They are supposed to be that close together. I guess Kozo makes smaller nuts than me, I don't know, but I got out the Prussian blue because I want to know exactly where it's fouling so that I can see if I can fix it. This is just standard model engineering. Things don't always go to plan. Things foul on each other. You can see that my mounting bosses are probably a little bit crooked. The threaded holes are not well centered on them, but that's kind of by design. The bosses are oversized to give you a target to hit. But I could see from the Prussian blue that the top right corner of that boss was touching. The other one was not, just this one, because this one was shifted up a little bit more. 20 or 30 minutes of character building filing, and this will be solved. You can see that I'm using my thumb as a filing guide. It's one of the many, many advantages to putting safe edges on your files is that you can use your hand in this way. It gives you really good control, and of course you don't turn your thumb into pavement pizza. Fortunately, I didn't have to remove too much of that area. Plenty of strength left in there to hold the screw, and now that fits on there very nicely. These detail pieces are a lot of work, but boy, they sure make a difference. They really make it look like a locomotive. That's looking nice. Now, you might have noticed there's another row of threaded holes here. Now we need to make the little clamps that go on those holes. The smoke box door would be clamped in place with some tiny little clamps. And of course, the smoke box door is not real, but we still want to make the clamps so that it looks like it's real. These parts are a great use case, I think, for what I call the bread slicing technique. I've got a piece of brass set up vertically. I've milled the top and the sides to dimension all in one setup. And then I'm going to drill a hole all the way down through what will become all 6 parts. And then we're going to be slicing them off one by one like bread. This works really well for these small pieces that are mostly flat and when you need a lot of them. I'm touching off on the saw, and I've calculated how much vertical material I need for 6 parts plus the saw kerf between each one. And there we go, 6 almost finished blanks. Now they need a little step on them, so I decided a fixture was the way to go here since I got 6 of them to make. A little scrap of aluminum, a couple of quick milling cuts to make a holding area and a step for the pass that we're going to make, and then a little threaded hole to use the hole that's already in the part to hold them in the fixture. The idea with this fixture is that, of course, it's highly repeatable, so I don't have to measure anything, and it holds the part all the way around on the sides and with the bolt, so it's very well secured, even though it's a very tiny part, so I can fearlessly take one big swipe all the way through to cut the entire step. If I was trying to hold this in a vise or something, it would be really difficult because there's not a lot of meat there to hang on to. These parts are so tiny, and I might have to take a lot of light cuts, but a fixture held them very securely, and it was super quick to cycle through all 6 of these parts doing this. No measuring, no edge finding, nothing. Super quick. Of course, they were still rectangular at that point, and you'll see they now have a little rounded end and some rounded corners on the back, and I did that with hand filing. Again, because they're so small, none of my elaborate machines or fixtures was really a good fit for that. So hand filing it was. There we go, 6 clamps on a fake smokebox door. Those little details really make a huge difference. Really happy with that. It's really looking like a locomotive now. Well, that was a lot of fun. I like making those detail parts. I hope you enjoyed watching me do it, and thank you so much for watching. Thanks to my patrons for making all of this happen, and I will see you next time.